Uh, Hello everyone. Today we'll try to do some examples on design of tension members. Let us consider first examples. Design a single angle sections for a tension member of a roof truss to carry a factor tensile force of 225 kN. The member the member is subjected to the possible reversal of stresses due to the action of wind. The effective length of the member is taken as 3 meters. Use M20 sharp bolts of grade 4.6 for the connections. This is the given problems. So our first step is to, as soon as you see the problems, our first step is to calculate what is the grass area required. So grass area required. So that is AZ. How to calculate AZ? We can calculate AZ by using factor load into gamma m naught divided by Fy. As we discussed earlier, so our first step is to calculate grass area required. So here the factor load is already given. It's a 225 kilonewtons into gamma m naught is the partial safety factor, that is taken by 1.1, and Fy is 250. So we calculate the what is the grass area required. So after calculating the grass area required, so we need to increase it approximately 30%. So increase it by 30% means whatever the area I will get, it should be multiplied with the 1.3 times. So we'll get 1287. So in this case I got 1287. So if you convert it into centimeter, it will be 12.87 centimeter squares. Now you need to select the angle section by using steel table. For required areas, we need to select the angle sections from the steel table. So now I selected this angle like ISA 100 mm by 75 mm by 8 mm from the steel table for the required areas. Then for this angle, we have grass area is 1336. So means it has little bit more than the required. This is required grass area. So I selected this cross section, so it has a grass area of 1336 millimeter squares or 13.36 centimeter squares. So this is your first step. First step is to calculate grass area required. Then by using that, you can select the required angle sections for the required angle sections. Now your next step is to you need to find out number of the bolts required for the connection. So we need to, next step is to calculate the connections, or you need to find out what is the number of the bolts required. For that I need to calculate the strength. I need to calculate what is the shear strength of the bolt and bearing strength of the bolt. So by using that, I need to select the bolt values. Then by using that, I can calculate what is the number of the bolts required. So here they given M20 bolts means of grade 4.6. Means the diameter of the bolt will be 22 mm. So we can assume what is the thickness of the gusset plate. So in this case, I assume it is 10 mm. So now let us check the strength against the shears. So now I need to calculate what is the shear strength of the bolt. So if let us assume that shear plane will occur in threaded portions. So shear place will occur in threaded portions. So by using that, then I can say number of the shear plane in threaded plane is 1, and number of the shear plane in shank portion will be 0. So by using this formulas like VDSB equals to FUB by square root 3 into NN into ANB plus NS into ANSB into 1 by gamma MB. So is there in page number 75, guys. So the page number 75, it clearly says regarding connections. Now first please remember, in connections your first step is to calculate shear strength of the bolts. Then so by using this, so here FUB is 400 because its grade is 4.6. So for ultimate strength of the bolt is 400. So by using this, I can calculate VDSB. VDSB I calculated it is 45.27 kilonewton. Next, strength. Now we need to calculate what is the strength of the bolt in bearing. So here Here you can see this is the strength of the bolt in bearing. So we have formulas. VDPB equals to 1 by gamma MB into 2.5 times the K into B into T into D into T into FU. So here K is some constant we need to calculate. So then D is the diameter of the bolt, T is the thickness, and Fu is least thickness. Guys, please, least thickness we need to consider, and Fu is the ultimate strength of the plate we need to consider. So now, so to calculate KB, so is there in page number 75? Guys, please, whatever the KB value, it should be, whatever KB value we will calculate, it should be smaller of all four conditions. So now, for that I need some pitch. So pitch you can calculate by using this relations, like what is that, 2.5 into D. D is diameter of the bolt. So 2.5 into T, so it comes to be 50 mm. So I adapted 60 mm. Similarly, I calculated edge distances. That is E equals to 1.7 times into D naught. So it is 37.4 mm. I adapted 40 mm. Now I already said your KB should be smaller of all these four equations or conditions. Now, so from these conditions, E by 3D naught, I got 0.606. Similarly, for this condition, I got 0.66. Similarly, for this, I got 0.97. And fourth one is the 1. Then you should be smaller of all four values. Then that is KB should be taken as 0.606. So guys, please, how to calculate KB, and please is there in page number 75. Please go through that. So now, so by using this KB values, I can easily calculate. By using KB values, I can calculate what is the strength of the bolts in bearing. So substitute here. What is the least value? 0.6066 here. D is the diameter of the bolt. Then T is the thickness, and Fu is the 420. So I got VDPB equals to 77.568. Therefore, your bolt value means least of, it is a least of VDSB and VDPB. Least of VDSB and VDPB. Please remember, we need to take bolt value should be least of least of those two values, VDPB and VDSB and VDPB. So again, next you can easily calculate what is the number of the bolts required. So force means factor load divided by the bolt values. So I can calculate what is the number of the bolts required. So for my this given problems, I got for these connections, I got 5 number of the bolts is required. So required. Then here I drawn the what is the connections of this thing. Connection of the single angle sections. So here pictorial representation of that one. Here you can see this is length of the connecting leg, and this is the length of outstanding leg, and here you can see there is a C value is there. What is that C value or WL? So we'll come to know this terminologies afterwards. What is that C is taken as WL, that is 60 mm. So it will taken from page number 168 SP6. So steel design handbook, there we taken this, means the distance between here to first bolt line here to here, means let us take from distance between top of the, for in this case distance between top of the connecting leg to the point where the bolt line is provided. So here it is bolt line provided, so that is C or WL taken, that is 60 mm. So here that is given, and the thickness will be 8 mm. So is a pictorial representation of the connections. Now as soon as you find out the connections, your next step is to you need to check for the designs. Whatever design design you did, you need to check against the mode of the failure. So please remember, I already explained you in the last class. So tension member fails in the mode of failure for tension member 3 types. Mode of failure for tension member 3 types. What is that? Strength failure due to yieldings, so failure due to yieldings, then failure due to ruptures, and failure due to black shears. So we need to check strength against the all 3 parameters, all 3 mode of failures. Then check, let us consider one by one. Now let us consider strength against the yielding or yield strength. So it is given in page number 32. Please page number 32 of IS 800. There TDG equals to, it will give the yield strength. TDC equals to AC into FI by gamma m. AC is what? Gross area required. FI you already know, it's 250 by gamma m naught is 1.1. So it should be greater than the factored load. Please remember, it should be greater than the factored load. So I got I calculated. So I got for my selected sections. So yield strength I got 303.636. So it is greater than the factored load. Hence it is safe against the yielding. Then next you need to check what is the strength against the ruptures. You need to check strength against the ruptures. So it is given in page number 33 IS 800. So the formula is for strength against the rupture is what? Rupture strength will be TDN equals to 0.9 FU ANC by gamma ml plus beta into AZ naught into Fy by gamma m naught. Here beta is given in here. How to calculate beta? They given this condition equations. So here we use you can see here we use some terminologies like ANC, AZ naught and all those things. So what are those things? So I drawn here the angle sections here. I drawn here angle sections. Guys, please, the angle or the leg which is connected to the gusset plate is connected leg. The leg which is outstanding, so it's not connected to the gusset plate, is called outstanding leg. So here let us take the length of the the total length of the gusset plate is A and total length of the outstanding leg is B. So here AG naught means what is that? Area of outstanding leg. How to calculate area of outstanding leg? We can easily calculate the area of outstanding leg by using these conditions. What is that? So we need to take what is that? Effective length of the outstanding leg into the thickness. What is the effective length? B. This is a B minus T by 2. So guys, please, we need to consider effective length, means we need to deduct the center line. You need to take at the center line here to here to here. So here to here we need to consider, means we need to do T by 2 into T. So I got 568 millimeter squares. This is area of outstanding leg. Similarly, I need to calculate area of connecting leg. How to calculate area of connecting leg? So total length of the connecting leg means it is A. Total length of connecting leg that is equals to A minus D naught, means we need to deduct the bolt hole. We need to deduct the diameter of the bolt hole minus T by 2. I already explained you, we need to take effective length here to here. So T by 2 into 2. So I got the values. Area of connecting leg is 592 millimeter squares. Then while calculating beta, you can see while calculating beta we have several terminologies here. What is W, T, BS and LC? What are all those things? W means this is the length of the outstanding leg. This is the length of outstanding leg. And BS means the base shear lag. So BS is base shear lag is given in the code book. So you can in page number 33 they clearly explain what you mean by this thing. So here BS we can calculate W plus WL minus T. I already explained you where you have to take these WL values. So we taken from SP6 page number 168. There we considered what is WL. So we calculated is 60 mm and BS is 75 mm. Means this is the length of outstanding leg minus T, means T is the thickness of the angle section. So it is 127 mm. Then LC means guys, please, what is the LC? LC means, so I given here the LC means distance between the outermost bolts. LC is the what? Distance between the outermost bolt. That is the LC. Means here to here pitch. Here to here is 60. 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 Total how much it is? Total 240 mm. Distance. Please remember LC is nothing but the distance between outermost bolt. Distance between outermost bolt. Then so we can easily calculate so beta here by using that whatever the find out now by using that we can easily calculate what is the beta here. So calculate beta. So based on that I calculated the beta. Guys, please, I calculated the beta. So I got like it's 1.17. It should be lesser than these values. So what is this? It should be lesser than or equals to Fu by gamma m naught by Fy by gamma ml. So it is 1.14 and it should be greater than the 0.7. So I got beta value is 1.17. Then that is okay. Then you substitute whatever the value you got, substitute in these conditions, TDN. So then whatever you got, you substitute in these equations. So then I came to know DDN equals to, I got the values of 325.799 kilonewton. So it is greater than the factored load, hence it is safe. So whatever the value I got, TDN, it is greater than factored load. Now, so next, guys, you need to check for the strength against the shear, black shear. Sorry, you need to check strength against the black shears. We need to check strength against the black shears. So is there also there in page number 33 IS 800. Guys, please, I drawn the connections, redrawn the connections once again here. So what will happens when you apply a load? When you apply a load, it will tend to shear like this. It tend to shear like this, and this line is subjected to a shear, and this line is subjected to a tension. Means when you apply a load, it will fail like this, Then, so here in IS code book, so we have given the formulas like strength against the black shears. What is that? TDB equals to AVG into Fy by square root 3 of gamma m naught plus 0.9 ATN into Fu by gamma ml, and TDB equals to 0.9 AVN by Fu by square root 3 gamma ml plus ATG into Fi by gamma m naught. So these two formulas are given to find out the rupture strength of the to find out a strength against the black shears or black shear strength. So here you can see in this formula we have some terminologies like AVG, ATN, AVN and ATG. What is those things? So that is what. So that's I explained here. They explained here. When you apply a load, so it will tend to shear along this line. So and is subjected to tension on this lines. So here again, so this is a shear line. When you apply tension, it's subjected to a shear line. It subjected to a shear along this line. So it is also called a shear line. So the length of shear line is given by 280 mm. So here to here is 240 mm. Remaining edge distance we add, it will be 280 mm. So this is length of shear line. LV I given is a length of, V means shear. Length of shear line means this line is subject to a, means when you apply a tension load, guys, please remember, when you apply a tension load, it will be failure pattern will be like this. Means this line subjected to a shear, and this will be subjected to this half of the bolts, and here is subjected to a tension. So it fails by tension. This line fails by tension. So that's why it's given LT. This is given LT. So here, then let us calculate what is the, you need to calculate AVG. You might be seen in that formulas, the terminology AVG. What is that? Gross area parallel to the load. Means what is the gross area parallel to the load? This gross area parallel to the load. How to calculate gross area parallel to the load? The length of the shear line. Please remember, the length of the shear line into thickness we need to do it. So we will get gross area parallel to the load. Please remember, length of the shear line into thickness we need to do it. We will get the length of the gross area parallel to the load we will get. Gross area parallel to the load we will get. So that is AVG. How we need to calculate? LV into T. Similarly, what is the net area parallel to the load? Means we you need to calculate what is the net area parallel to the load. So how to calculate this AVN? So the AVN, that equals to AVG, means gross area parallel to the load, that minus net area, means we need to deduct the number of the bolt hole along the shear line. So how many number of the bolt hole here? 1, 2, 3, 4, and half of this one you need to take. So how many number of the bolts hole here? 1, 2, 3, 4, and half of the bolt hole we need to consider. So total, you can see total 4.5 number of bolt holes are there along the bolt holes are there along the shear line. So that into 22 means diameter of the bolt hole into T means thickness of the bolt. So it comes to be 1448 millimeter squares. So here also I given star mark. What is that? Number of the bolt holes along the shear line. So the star mark is number of the bolt hole along the shear lines. That's how we need to calculate AVG and AVN. Similarly, let us calculate what is the gross area perpendicular to the load. So means gross area you need to calculate grass area perpendicular to the load. So here, how to calculate grass area perpendicular to the load? This is the load. This is the perpendicular line, right? Grass area perpendicular to the load. This is the load. For this load, this line is perpendicular. So what is that? LT into T, we need to do it. So LT into T means here you can see the same thing I did here. So ATC equals to grass area perpendicular load LT into T. Similar way, I calculated what is the net effective area perpendicular to the load. How to calculate? ATZ minus ATN, that equals to ATZ minus number of the bolt hole along LT. How many number of bolt holes are there? Only half. Yes, please. We need to consider half of the bolt hole. Along this line, how many number of the bolt hole? Only half. So half into diameter of the bolt hole into 8 mm. So it is ATN. This is how we need to calculate. AVZ, AVN, ATZ and ATN. Then substitute in these formulas, we will get TDB equals to 362.410 kilonewton. It is greater than 225 kilonewton. Once again, and we need to check this formulas. TDB equals to this, so I got at least 319.515 kilonewton. It is greater than the 225 kilonewton. Hence it is safe. Guys, please, whatever the angle section you selected, it should be satisfy all three mode of failures. So all three mode of failure. Hence you can say your selected angle section is safe. Hence it is selected angle section is safe means it should be greater than strength against the yielding, strength against the rupture, and strength against the block shear should be greater than the factored load. Please remember. Then you can say the selected angle section is safe. Now, so there you need to check for the reversal of stresses. So means the tension member subjected to a reversal of stresses due to the wind means we need to check for the slenderness ratios. If the problem given like this, then means we need to check for the slenderness ratio, means lambda. What is the slenderness ratio? Lambda is given by effective length by the R minimum. What is R minimum there? R minimum is taken as a radius of gyrations. Lambda is effective length. Effective length is given 3 meters means 3000 mm divided by 12.7 mm is R minimum. So it is I got lambda is 236 mm, so it is lesser than the 350 mm. Please remember, for the reversal of stresses due to the wind load, whatever the lambda is there, it should be lesser than the 350. In these problems, I got lambda equals to 236 mm, so hence it is safe. Please remember, lambda should be lesser than 350 for reversal of stresses due to the wind. So then where I got the R minimum means we used to get from the steel. For given angle sections, we need to take the radius of gyrations from the steel book. They used to give there the value of R minimum is given there, you need to take it from the steel book. So for the particular angle sections, we need to take it from the steel book. So here for my angle, selected angle sections, R minimum is 12.7. That's how we need to check for the reversal of the stresses. This is how we need to do. This is now we need to do the problem. So now let us consider